Hello everyone. Hope you are doing well. Hope you are doing well and you have been following me since my few videos. And in the last class, we had discussed a lot about kinetic energies, different kinds of kinetic energy per mole, per molecule. Uh, Today, we are going to discuss something relating to Maxwell's distribution. Uh, Maxwell's distribution is basically a distribution of velocities of molecules in a particular gas. So before we actually start with Maxwell's distribution, there are so many examples where in our real life that we can connect with distribution. Now Maxwell's distribution is also called as the normal distribution. If you can just see on the screen, this is what is called as the Maxwell's distribution, or it is also called as the normal distribution, and it is also called as the bell curve. And this is called as bell curve because of its peculiar shape like a bell. So if you see, its shape which is going initially up, attaining a maximum value, and then it goes on decreasing. So let's take an example of a regular example out of physics, wherein we have this thing called as number of people were plotted on the y-axis, number of people of a particular country. So let's say this data represents a data of a country, and the number of peoples in a country is plotted on the y-axis and their age is plotted on the x-axis. Depending on these two variables, the graph was plotted, and the graph came out to be somewhat like this. Definitely, in any country, there will be a particular age where the number of people would be maximum, which is actually signifying this peak. So, like a country like India, the maximum people of a particular age is 28. So, you will at present, I mean, right now, I am recording this video in 2025, and in 2025, you will find out that the average age, maximum number of people in India is around 28. So how does this what information does this graph show us? It signifies that we in India, we also have people of 100 and 104, 80, 90 people, but then those people are very less. And uh, there are people, and the kids who are just born, so that is very near to the age is right now very near to 0. But then yes, the peak value is here, so there will be around crores of people staying here. That's why the graph is looking at starting at 0, but actually it will start slightly above, and even this as well, like it will definitely go above 100, because there are people who are alive up to 104, 110 years of age as well. Now this is particular for this one country, but if you go to some other country, you will definitely find out the graph may be different. Some country where the maximum number of people who have an age of let's say 50, then this graph would look somewhat like this, But if you see, the graph is going to be like this. Now if you see, yes, definitely the population has also reduced. So earlier the population was much higher, much lesser now, but the peak has shifted to this particular age. So this could be 50 years as well. So maximum number of people in that country is 50 years. Yes, if you see, the end part is also shifted. So that means this in the country which is blue, represented by blue line, are living more. Like they might be living till 102, 110, 120 years as well. And there are blue zones in the world. We call it as one is Okinawa, where in Japan, where people are generally living more than 100 years. You can just go and search on the internet on regarding blue zones and Okinawa people's way of living. So yes, but then there is a counter data as well. Like there might be some country in which the graph would look somewhat like this, the green graph, and if you see, this country is really struggling, like the countries in which there are a lot of political unrest, geopolitical issues, uh, Niger, and there are so many countries, Palestine, and all those countries where wars are being done, famines are there. Some African countries like Niger is one. So if you see the average age, the maximum number of people they are alive are is somewhere around 15 or maybe 20 years of age. This would be their peak. And as people age, because of unrest, because of people joining into fighting, wars, their actual age ends up somewhere around 35 or 40 maybe. That does not mean that people might not be of 80 or 90 years, but then that's an odd data for that particular country. So if you see this, all three graphs actually signifies one thing, and that signification is that everything is a kind of a bell curve. All the graph shows a bell curve. Okay, so this is basically a representation of a statistics. Now coming back to the another graph where we can say if we have number of students on the y-axis, okay, and marks on the x-axis. This is generally data published for many particular universities and boards after the exams are over, after the results are declared, that how many students passed in with how many marks, who got maximum marks, all those stuff. So let's say for some university, some board, the full marks is 100. So the marks were out of 100 and the passing criteria was 35. So if you see this graph, this will be a quite familiar graph. Number of students is plotted on the y-axis, marks is on the x-axis. So no student is going to get more than 100 marks, no student is going to get below 0 marks. 35 is the passing, and the irony, the truth of life is that most of the students just cross the line, So there will be a lot of students in this peak, and 35 marks will be perceived by a lot of students. Yes, we'll have some students who are getting 100 out of 100, full on full, but this would be a rare data. You do not have thousands and thousands of students getting full marks. Neither you will have students who are getting 0 out of 100 in thousands. No, you will have very rare students who might have really made that effort to get a 0. But yes, there will be a lot of students who will be in this particular age. Now this graph can also shift, this graph can also move on a condition that if the paper was, the exam was, the paper's difficulty was pretty less, the paper had come much easier, then a student who was supposed to get a 35 may also get a 50. So the graph would, oh my goodness, I just moved ahead of 100. Okay, so the student might get marks of maybe 50, somewhere around here, 50 marks. Okay, the peak shifted, and the reason behind this, the paper was pretty easy. So a lot of students are getting more than 35 marks. And this again, you have a counter example as well, like if the paper came out to be much difficult and students are not able to just cross the line, and now the number of students who are getting lesser marks is less. And if you note this, I have always touched this over here, but in this particular graph I have changed the end point, because age could be ending on any part, but marks, maximum number of marks is 100 for this particular exam. So here the peak comes out to be somewhere around 17 maybe, and here the peak comes out to be somewhere around 50, and here the peak is somewhere around 35. So if you observe this, the graph can shift, but yes, this is a distribution, and it again goes into a bell curve. Now these are the two examples which actually builds your concept, which actually builds up the analogy over here. This is the final example which we are about to discuss in the entire video. Like our target was this itself. Okay, let's say if we have a particular gas somewhat looking like this. Suppose we have this container, and in this container we have molecules of gas. They are continuously random motion. So if you can see all the directions of motions I have shown, and molecules are never at rest. That was the first assumption when we were discussing assumptions of kinetic theory. And we also discussed that molecules move with a constant velocity between collisions. So after one collision, after this between two collisions, the velocity of the molecule is constant. Yes, they can change velocities, but for that they need to collide. Now, if you see, I have plotted number of molecules in the y-axis and the speeds on the x-axis, and let's say suppose this gas in which the maximum number of molecules, which is n, they are moving at 500 meters per second. But this does not mean that the molecules has 500 meters per second speed. Yes, there will be some molecules which might be moving at 1000 meters per second, and there will be molecules which will be moving at very slow 1 meters per second as well. Now, you should note that yes, there are molecules which are moving with lesser velocity. I'll write this, wait. Yes, so there are molecules which are moving with a speed of, let's say, 200, and there are molecules which are moving at, let's say, 700 as well. But while these molecules move in a random direction, they might collide, and a faster moving molecule may slow down, and a slower moving molecule may pace up, that is, it may become fast. So if a faster moving molecule is hit by some slower moving molecule, let's say this one, then the slower moving molecule will be faster, so this viscous speed will increase and the molecule will shift towards the right hand. And if the faster moving molecule is hit, like if this is the faster moving molecule, if it is hit by a slower molecule, then probably it is going to slow down. So again, this distribution, the curve, the bell curve does not change its shape. It will just keep on, the molecules will keep on shifting from faster to slower. Some molecule which is here moving now, it's faster, but then faster moving molecule will become slower, and it will keep on happening like that. Yes, we can change the look of the graph. Like if we heat this, let's say I'm heating this. Let's say I'm heating this gas. Now, as we have understood that temperature and CRMS, that is just a minute, CRMS, that is the velocity, or I would just write speed. Speed actually depends directly on the temperature. Okay, now I'm not writing it's a function, because actually CRMS is equal to square root of 3 RT by m0. So molecules ka velocity is depending directly on square root of temperature. So if you heat that gas, then definitely your peak, the graph's peak would definitely shift ahead. I'll do this with a different color, wait. Okay, so the graph would move like this, and now the molecules are moving with a different velocity and with a greater speed, and more number of molecules are faster. So this is what the distribution of velocity of molecules in a particular gas is, and this is what is called as Maxwell's distribution. Hope you have liked this video, and you have understood the concept of molecular speed and Maxwell's distribution. Thank you so much for watching. Please do subscribe the channel. And please comment on the video, so I would know if you are able to understand, or if anything else has to be covered. Thank you so much. Bye.